next is going to show you how to calculate solubility from KSP. So in this particular problem, we're dealing with strontium sulfate, and we know the KSP is 3.2 times 10 to the negative 7, and they want us to calculate the solubility in grams per liter. So we know that the KSP expression for this guy, well, actually, let's start with an equation. That's always a great place to start. SR-SO4 is a solid, and not much of it will dissolve, but will dissolve into strontium ions and to sulfate ions. So the KSP for this reaction is going to be Sr2 plus times the concentration of SO4 2 minus. All right, now we'll do our icebox and don't have to worry about the solid. And at the beginning, we're going to have no ions because we haven't put this in water. And when we put this in water, we're going to make some ions. How many? I don't know. So let's just make it X. So that means this is plus X. It's a 1-to-1 mole ratio. We're still on the same side of the arrow. So this is also plus X. So that means those are my equilibrium concentrations. Now, I'm going to plug these concentrations into my KSP expression. So I have 3.2 times 10 to the negative 7, because that's my KSP, equals my concentration of strontium ions, which is going to be X, times the concentration of my sulfate ions, which at equilibrium is going to be X as well. So that means that 3.2 times 10 to the negative 7 equals X squared, and just take the square root of both sides, and I end up with 5.7 times 10 to the negative 4 is my equilibrium concentration of strontium hydroxide. So this is 5.7 times 10 to the negative 4. So is this one, 5.7 times 10 to the negative 4. This is how much of strontium sulfate that actually dissolved, and there is a 1-to-1 mole ratio here. So if these are the amounts of ions that produced, that means that 5.7 times 10 to the negative 4 moles per liter, because that's what square brackets mean here, and that's what we were calculating here in our icebox. That's how much of that strontium sulfate actually dissolves. So right now I have the molar solubility. What I'm going to do now is I'm just going to convert very quickly my molar solubility of this to my grams per liter. So moles to grams, in 1 mole of strontium sulfate, it has a molar mass of 183.69 grams. And I end up with 10 grams per liter of strontium sulfate will dissolve. And that is the solubility in grams per liter. Now, let's look at the molar solubility of silver chromate here, and they give us its KSP. So this is going to be a little bit easier. We won't have to go through the molar mass step. So again, it's always good to start with a reaction. CrO4. And this is our solid. Not much is going to dissolve, but what does will form a saturated solution. Don't forget to balance your equation, so I actually have 2 silvers here. Now I'm going to do my icebox, and alright, at the beginning I would have none. Now, looking at this, when this guy does split up, I'm going to produce 2 silver ions and 1 chromate ion. So when I go to decide ions, I'm going to make the one that's a 1-to-1 mole ratio with that solid X. It's going to make some ions. I don't know how many. So this is plus X. So this is going to be plus 2X. So I'll get 2X here. Now, I have my equilibrium concentrations. I can plug that into my KSP expression. So this is going to be my silver ions squared times my chromate ions here. And now I just have to plug in my numbers. 9.0 times 10 to the negative 12 equals x squared times x. And then I get x cubed. And then I just have to take the cube root of both sides. So for that one, so with that I get x to equal 2.1 times 10 to the negative 4. That is my equilibrium concentration of chromate, and this is in molarity. So this is why I chose X here, is because it is a 1-to-1 mole ratio. So this many ions split up of or were formed of this, so that means that much of this split up. So 2.1 times 10 to the negative 4 moles of Ag2CrO4 will dissolve per liter. So that is its molar solubility.